Now, one thing, there's a lot of the stuff in the book, my heroes all over Heaviside, that inferential schemes, okay, we have a correlational picture from which we study the validity of inference rules. It's often proved that the inferential rules are pretty good and the picture was wrong. The classic case is Heaviside, but there's modern mathematics, applied mathematics is thoroughly full of these reversals. What we really meant in our equations was something else. And basically the philosophy is there's an obscure English mathematician has said, a method which leads to true results must have its logic. Now, to me, this is the proper expression of scientific realism, not that Richard Boyd, Hillary stuff about reference and so forth. But if you have a reasoning method that works well, there has to be some correlational story that does not, and usually isn't, some sort of naive name to reference sort of relationship. But there has to be a correlational story that allows you to underwrite the soundness of the reasoning technique through its correspondence to the reality you're modeling. And a lot of times you shift your picture of what's actually going on physically to get this to work. Okay. And in these things, you often say, we didn't change the meaning of any of our terms, we just got its underpinnings right. There's a wonderful quote from Hans Louis, the mathematician, but we'll have to skip that. So these episodes of semantic recalibration do have kind of more of a Neurath-like sort of character. Okay. But what I want to emphasize, despite the fact that these are little twists and turns, the ability to loosen the shackles of traditional constraints upon scientific conceptual liberty can be quite as effectively executed by these sorts of shifts. Okay. And I don't think that philosophers have realized the extent to which almost all the classical mechanics, classical electromagnetism, has undergone quite large-scale shifts in their technical understanding, motivated by people like Heaviside. Okay, so this is why I go back to the late 19th century and the guys like Picard and so forth. You can implement the spirit of scientific philosophy and its approach to concepts, particularly liberty, without needing to embed everything in axiomatics. In fact, quite the contrary. Under these kinds of shifts, and this, I believe, happened in classical mechanics, what you actually wind up is a field of improved doctrines that are manifestly not able to be axiomatized. Okay. Because these little shifts optimize local adjustment and utility of the equations, so they don't need to fit together in a pattern of axiomatization. Okay, I more or less said that. Going back to Hertz's problem, we now have a very good understanding of why there were tensions in classical mechanics, and the way of resolving them is to localize and pay attention to the localized significance of force and be careful about shifting conclusions about the word force from one context to another without paying attention to the information that they bear, which we have arrived at by these correlational studies. Okay, now this would be my approach to Michael's problem. I don't have time to go through it, but there's a lot of these things about the semantics, how people handle the reliability of inferential rules that would give you a kind of a justification of the value of Helmholtz thought experiment type stories, more in this vein, and thus avoiding the need to make anything be a meaning postulate. So that, okay. This is a kind of view, I was trying to be nice because you have a lot, but we do that here. Okay. Yeah, so the proposal I'm making and kind of suggesting that the way we do it is paying more attention to these delicate tools about studying correlations between effective reasoning and the world in the spirit of applied mathematics. It seems to be, strikes me as a form of scientific realism, but not of that crude Putnam-Boyd type. By working in this way, we can tell a story in which philosophy, just as Michael wants, can again serve as a non-trivial critic of established concepts. But mainly by borrowing from case studies drawn from applied mathematics of how words can look like they're working under one sort of inferential pattern, but there can actually be alternative stories that back up the words in a better way. That's the moral of the Heaviside episode. People thought the derivative worked this way. By studying what was actually giving Heaviside his great results, you actually see it can work a different sorts of way, and the concepts can have more, kind of mimic one another in how they are semantically supported. If philosophy is more alive to that kind of possibility, it could be helpful to unraveling conceptual difficulties when they arise in all sorts of contexts. Okay, and I'm advocating that we return to that mission, which is part of the scientific philosophy heritage, and I think I can stop. Oh, okay.